Welcome, geometry students. Today we're going to learn how to use properties of trapezoids and kites to solve problems. As we're working through today, I want you to think about how we worked on parallelograms to solve problems, because what we're going to do is use the traits of these two figures, specifically trapezoids and kites, to set up equations and find information about the shape. So let's start talking about our trapezoid definition. A trapezoid is simply a quadrilateral with exactly one pair of parallel sides. So we're still dealing with a four-sided figure, but this is not an example of a parallelogram because this is exactly one pair of opposite sides parallel, where a parallelogram would require two pairs of opposite sides parallel. An isosceles trapezoid, think about the word isosceles triangle, which means we would have two or more equal sides. So an isosceles trapezoid is similar, only it's a trapezoid with congruent legs, just like an isosceles triangle is a triangle with congruent legs. So let's take a look at the pictures. In your annotation section, it says to draw the trapezoid here. So a trapezoid would look something like this. It's a four-sided figure, and one pair of sides is parallel. We call the parallel sides, by the way, the bases. So base 1 and base 2. It doesn't matter in which order those are, it's just a way to classify them. And then the other two non-parallel sides are the legs. So once again, it does not matter which one is leg 1 and which one's leg 2. It's just stating that there are indeed two legs. Now in an isosceles trapezoid, you're going to have something unique happen. We still have one pair of opposite sides parallel, but the key is here that the two legs have to be congruent. So I've marked that with our tick marks. So the length of leg 1 would be equal to the length of leg 2. Now because of that, we have some parallel angle relationships. What we can also go on to say is that the upper base angles and the lower base angles are going to be congruent. So we have two pairs of congruent angles. Now if you look at this, the angles are always on the ends of the parallel sides, meaning here's one parallel side, so the angles touching the vertex of that are going to be congruent. And then the other parallel side is what we would call the lower base. Those lower base angles are congruent because they're the ends of, meaning the vertices, created by the other parallel side. So it's not saying that these two angles would be congruent. Those would actually be supplementary because they're consecutive interior angles. Alright, so there's a lot of properties we need to know about an isosceles trapezoid. So this is not about any trapezoid, but specifically isosceles. Property number 1 is the base angles of an isosceles trapezoid property. If a trapezoid is isosceles, then each pair of base angles is congruent. And that's the fact that we were just discussing. So let's say our image is drawn this way. So now our parallel sides are going up and down. Well, if we look at the upper base angles, remember the parallel sides are always the bases. So this is our upper base. And again, upper and lower, it doesn't really matter. They could be switched. The endpoints of that are going to be congruent angles. So those upper base angles are congruent. Then the other parallel side, the endpoints of that, making that vertex and this vertex, are also going to be congruent. And then the angles that are not congruent are going to be supplementary. Now keep in mind this has to be isosceles, so those two legs are congruent. So this does not happen in a regular trapezoid. Property number 2 deals with if a trapezoid has a pair of congruent base angles, that it is an isosceles trapezoid. So this essentially is looking at a way to show it's a trapezoid given information about the base angles. And keep in mind, it's just a pair, so it doesn't have to be both pairs. If one pair of base angles is congruent, then the others are going to be as well. Finally, property number 3, the diagonals of an isosceles trapezoid. A trapezoid is isosceles if and only if its diagonals are congruent. Now keep in mind this phrase, if and only if, is an example of a biconditional. That means that this statement's automatically reversible. So we can write it in this order, or we can write the converse of the biconditional, and that would still be true. So if it's a isosceles trapezoid, then that would tell us that those diagonals are congruent. So if the legs are congruent of the trapezoid, we would need the parallel bases. Then that would mean that AC is congruent to BD. Now keep in mind, we don't know anything about these bisecting each other, meaning the diagonals. It's not a parallelogram, so that is not applying here, but we do know that the lengths of the diagonals will be congruent only when it's an isosceles trapezoid. Example 1 says to find the angle measurements. So we're asked to find angle C, angle A, and angle D. This is a trapezoid, but if we look at the picture, we can verify it's a trapezoid due to the 2 parallel sides. But even more than that, it's also an isosceles trapezoid since the legs A, B, and DC are congruent. Well, what we need to know then is that we have some congruent angle relationships. So if angle B is 135 degrees, its other base angle matching with it at the other end of that parallel line will also be 135 degrees. So we know angle C is 135 degrees. Now, if we look at this pair of parallel sides, and AB is a transversal, if those lines are parallel, then this angle and angle B are supplements. So angle A will add with 135 degrees to make 180. The reason why we can do that is if the lines are parallel, then the consecutive interior angles would be supplementary. So back to last unit. If we solve that, we're going to find that angle A is 45 degrees. Now, we could find angle C in 2 ways. First of all, we know it would be congruent to angle A because it's a base angle. So that would be 45 degrees. The other way to handle it is we know 3 of the 4 angles in a quadrilateral. So we could always subtract those 3 angles from 360 to find angle D. And we would find that angle D is 45 degrees. All right, moving along, if we look at the midsegment theorem for trapezoids, it states that the midsegment of a trapezoid is the segment that connects the midpoint of each leg, the midpoint of each leg. And I believe there might have been a typo in your packet. Could you please cross out base and put leg? Its length is equal to the average of the lengths of the bases. So let's take a look at what this looks like. So this applies to any trapezoid. Not necessarily does it have to be an isosceles trapezoid, but it applies there as well. So this is a trapezoid because we have exactly 1 pair of parallel sides. It says the midsegment of a trapezoid is the segment that connects the midpoint of each leg. So here's one leg, here's the other leg. Keep in mind the legs are the non-parallel sides of the trapezoid, and the bases are the parallel sides there. Okay, so we're connecting the midpoint of each leg. So if I were to find the midpoint of this leg and the midpoint of the other leg, and I connect that, that's the mid-segment. Now it's equal to the average of the lengths of the bases. So average we find by adding up the lengths and dividing by how many there are. Well, in this case there are 2. So we would add the length of the top base with this length of this bottom base and divide it by 2 to find the length of the midsegment. Let's take a look at an example of that. In the diagram, MN is the midsegment. So we know M is a midpoint of PS and N is a midpoint of QR. We want to find the length of MN. Well, we want to average the bases. So we do that, we're going to take and add 16 with 9 and divide by the number 2, since there are 2 bases. And when we do that, we find that we are dividing 25 by 2. Be careful if you input 16 plus 9 divided by 2, this whole quantity in your calculator, it's very likely it's not going to do the order of operations correctly. So you want to simplify the numerator to 25 and then divide by 2. Mental math would be good as well here. So we're going to find the length of the midsegment is 12.5. Keep in mind, a quick way to check your work is that should be between the lengths of the smaller and larger base. So it should be in the middle of those. That's a good way to make sure your answer is appropriate. All right, so that's what we're going to learn about trapezoids. Now let's move on to a kite. A kite is a quadrilateral, so still 4-sided figure, that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So consecutive, keep in mind, are next to one another. So a kite is exactly what we might think of. It looks like this, kind of like a diamond. So we have 2 pairs of consecutive congruent sides. So here are my 2 equal sides. This, by the way, is going in your annotation section. And then the bottom 2 consecutive sides are congruent as well. Now it might also look something like this, orientated a little bit differently. Here are my 2 equal sides. Here's my other pair of consecutive sides that are equal, and that would also make up a kite. There are 2 properties you need to know about a kite. The first is about the diagonals. If a quadrilateral is a kite, then its diagonals are perpendicular. Whoops, sorry about that. Diagonals play a very big role in this unit, so we want to make sure we recall the different properties of the diagonals. That's one of the properties that's often overlooked, so just be aware that that's something you want to pay extra attention to. Okay, so here's our kite. We know it's a kite because it has 1 pair of consecutive sides congruent and our second pair of consecutive sides congruent. Well, if we were to draw on the diagonals of a kite, they're always going to meet at a right angle, so they're perpendicular to each other. The handy part about this is that allows us to look at our 4 triangles, 1, 2, 3, 4, and realize that they're all going to be right triangles. Well, when you have right triangles, now we have options to use things such as our trig functions, we have options to use Pythagorean theorem, and so forth. So keep an eye on that. If you're looking for an unknown side, that might be a good resource tool to use. Property number 2, opposite angles of a kite. If a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Now the word exactly means precisely. It can't be 2 pairs, so only 1 pair of angles. So for example, if this is our kite with 2 pairs of consecutive congruent sides, the congruent angles have to be between the non-equal sides. So these 2 lengths are not the same. So this angle is going to be equal to the angle opposite of that. So it is not going to ever be the angle here or here because those are between the congruent sides. So it's always between the non-congruent sides. Again, if my picture were oriented the other way, same is true here. My non-equal sides, here's 1 pair of non-equal sides that are consecutive. That means that this angle is congruent to its opposite angle. It will always work that way. All right, example 3 says find angle T in the kite shown at the right. Well, if we look here, here's my 2 non-equal sides. So that's going to mean that angle R, the angle between those non-equal sides, is congruent to its opposite angle. So at first you might be thinking, well, I only know 2 angles of my quadrilateral. I can't find this. But I actually can, because those 2 angles have the same measure. So I can say that x plus 70 plus 88 degrees will add to be 360 degrees, the sum of all of the interior angles of any quadrilateral. So when I simplify this, I'm going to find that 2x plus 158 is equal to 360. Go ahead and pause your video and solve this equation. You should have found that x is 101 degrees. So since x was the same as angle R, we know angle R is 101 degrees, and we know angle T is 101 degrees, excuse me. There are no you try nows for this particular video, so just bring your questions to class tomorrow and we'll talk about those. Have a wonderful day.